Hello, my name is Joel George, and this is my gummy bear experiment. So these are the results of my gummy bears. These are my gummy bears that soaked for water in 8.5 hours. These are my gummy bears that were in the heavily salted solution. And then for comparison, these were what the gummy bears looked like ahead of time. I was kind of surprised. I knew the gummy bears in water were going to get a lot larger, but I did think the gummy bears in the salt solution were going to shrink down. But if anything, they are bigger. So not too sure about that. But we'll look into why this happened. Okay, so essentially what this experiment is measuring is osmosis, which the book defines as the selective passage of solvent molecules through a porous membrane from a more dilute solution to a more concentrated one. So that's kind of what's going on over here in this graphic. Note that the molecules themselves aren't moving, just the liquid. So this kind of illustrates what was happening here. So our key factors at play here are gelatin, water, salt, and sugar. The gelatin and sugar, of course, being inside the gummy bears. The water and salt solution being outside of that. So essentially what's going on here is gelatin does not dissolve in water, but sugar and salt do dissolve in water and are hydrophobic. So essentially, in our first experiment, the one with just the water, the gummy bear is surrounded by a whole bunch of water, and the water, there are some empty spaces there in between the gelatin proteins, so the water makes its way inside, and as in our graphic here, tries to balance out. So there's a proportional amount of solvent to solute. In our experiment here, water is the solvent. The gummy bear and salt are the solutes. Then, of course, in our experiment with the salt is another solute that is added there. Essentially what's going on is everything wants to even out. So like we were talking about in the first experiment with the gummy bears in the regular water, the gummy bear kind of swells up as water enters in. So at first there's all that water outside of the gummy bear. It works its way in. The water wants to equal everything out. In our second experiment, there is a lot of salt in the water. The first important thing to note is that salt molecules are smaller than sugar molecules, and we heavily salted the water, which, as we learned, makes that into a supersaturated solution. So theoretically, any water molecules in the gummy bear should have left to try to even out that proportion between solute and solvent. As we mentioned earlier, that didn't really happen. I don't know, maybe this is the kind of gummy bears I used. Maybe they don't have that much water in them originally. Or maybe I put the wrong amount of salt in the solution. Regardless, what should have happened is that the water should have left the gummy bear, and the gummy bear should have been smaller and maybe even shriveled up a little bit. So a real life example is blood cells. I was pretty excited to do this experiment because we, at my job at a vet clinic, this is kind of a real world example, of something that can happen, in the body. So, essentially, in real life, the blood cell is like the gummy bear, and each blood cell is surrounded by a protective semi-permeable membrane. So then we just have to make really sure when we're giving any fluids to pets or people, of course, for nurses, you have to make sure that any liquid entering the bloodstream is isotonic and at about the same osmotic pressure. So isotonic just means that it's well balanced out. We wouldn't want to, for instance, take that water that was very, very heavily salted and inject that into our bloodstream. That would absolutely cause some problems. An example of an isotonic solution is lactated Ringer solution, which we use at work every day. Another possibility is a sodium chloride solution. This picture kind of illustrates what really should have happened with our gummy bears there. So in the middle is the isotonic, or kind of our starting point, our ideal, what we want the red blood cells to look like. If there is too much water in the bloodstream, or too much solution in the bloodstream, the red blood cells are going to suck that up and get very large, and they could possibly explode or burst. And that's what's illustrated here. That would be hypotonic. Hypertonic is what theoretically would have happened to our gummy bears in the salt water. If in that case the fluid would leave the blood cell and cause it to shrivel up and crenate like so. So like we talked about, we just need to make sure to use an isotonic solution so we can keep our red blood cells isotonic. You can use solutions that are hypertonic or hypotonic. It just has to be really closely measured and monitored. So you wouldn't want to keep a patient on a hypertonic solution all day. An example of using one of these solutions that's not isotonic is if you have a pet that's really dehydrated. So if they're really, really dehydrated, their blood cells might start to look like these hypertonic ones right here, in which case you would probably want a hypotonic solution to help remedy that. But like I said, that needs to be very closely monitored to make sure it doesn't go too far in the other direction. Thank you so much for listening.